Hello everyone. So in this video we're going to be analyzing data using NLTK. So NLTK is Natural Language Toolkit, and when you analyze data what you're trying to do is you're trying to tell a story. And that leads me nicely into this, which is, let's consider a hypothetical world where we've got some countries are a crematorium, some countries are programming children, and some countries are maybe a research laboratory. Hypothetically, of course, obviously this is pure fiction, but it's just kind of, yeah, just a nice little story to fill out this video, really. So imagine there's this new world, and a research laboratory maybe produces a new wonder. I don't know, a new wonder injection, for instance, and obviously they need to do trial it for many years, prove that it's safe. You wouldn't want to do it otherwise, would you? So um, eventually, say hypothetically, the people in that country and in the I don't know, say all of these countries up here, the blue countries, the pink countries, and so on, say they all sort of started noticing slight problems with this injection and they wanted to analyze the data. Wow, what could you do? You could use Python, you could use NLTK. So let's consider we had some hypothetical data, of course, and let's just bring up some hypothetical data from. Let's call our company PFYZER, shall we? And say we had a text file from them that they'd had to release under duress, and it was 9 pages long, for instance. No, 30 pages long, and there was just hundreds and hundreds of potential problems, possibly hypothetically. And then here we go. We want to import an LTK in our brand new Python file. Then we want to use nltk.probability, and from that we want to use the class freqdist, FREQDIST, the frequency distribution for the outcomes of an experiment. A frequency distribution records the number of times each outcome of an experiment has occurred. When they say experiment, for this purpose, it is actually a text file of known issues. But because it's such a big file, we need to try and visualize and tell the story of what's going on here. So as you can see, from nltk.probability import freqdist. And then we pass it a sentence or a bunch of sentences, and then it should tell us the distribution and how many times each occurs within the block of text. So this may be new to you. This next bit, you probably would have seen something very similar before. So what we're going to do is we're going to open our text file that we've got called pfyzer.txt. We're going to open it read-only as f, so that's just the variable name. And then what we're going to do is we're going to read that into a variable. And with that variable, we're then going to tokenize it. Now, if you're not familiar with tokenizing in NLTK, say for instance, you had a sentence such like, I live in the UK. If you tried to separate that based on, if you tried to separate that, you would end up with something like I space live space in space the space U, comma, K, whereas tokenize actually knows that UK is one word, so it's more intelligent than if you just split it with Python code. So that's why we use NLTK. It's 2009. Wow. So then what we do is we say data equals nltk.frequency dist of the tokens. So we're just creating a variable from those tokens. And then what we will do is we'll filter the words. What we want to do is we want to pick out where we want to go through them. So we're going to say for mn, that's basically key value in the dictionary, because that's what we have here. It's basically the dictionary which has been created by NLTK frequentist. Then what we'll do is we'll say if the words are more than 3 letters long, then they're good words. One other thing that we need to do, and I had to add this in afterwards because, believe it or not, the reason I noticed was because one of the side effects of this fictitious document, obviously fictitious, not a real life document published by a company that's admitted to any errors. Just get that disclaimer in before I get banned. What we have is, without using lower, we had herpes with a capital H, and we had herpes with a lower capital H. What am I talking about? Herpes with a capital H and herpes with a lowercase h. So what I've done is here I've just said convert. So throughout, the key is actually the ailment, the problem, the issue, and the value n is actually the number of times it crops up within the document. So the filter words is just the name of my variable. Then if we print that, let's just uncomment that. I typed this out in advance just to check it worked, and it would be boring watching me type it, so it takes a little while. And yeah, so we're just printing the type, and it's a dictionary, obviously. So if let's get rid of type and actually print the words. And there are quite a lot of them, so it may take a second or two. Here we go. So you can see we've got the name of in fact, some of the conditions were several words. So I haven't gone as far as kind of, there we go. These are separated by a dash, so I think that's quite good. What we could go back and actually do is where there's a space, we could go back and put in a dash. But for now, I'm more interested in just starting to visualize the data. And what we're going to do is we're going to say for the key in the sorted words, so the key being the ailment or the problem, print, so that's the iterator, and then we're just going to say print the key and then print the filter words key, which is actually the number of times it occurs in the document. So this has nothing to do with number of times this has happened to somebody, this is just an analysis of the words and the number of times that each word or each phrase happens within the document. So just going to comment this out, and we'll go here and let's uncomment that. That's actually just going to iterate through all of them, and then it's going to print it. We should get a line of the keys followed by a colon followed by the frequency. And there we go, you can see it down here. So I think the highest frequency ones will be nearer the top. Oh no, it's alphabetical, sorry. Yeah, so chronic occurs 9 times. So without going through that list, that would actually take forever. So let's just create a variable called data1, and that's equal to the frequency distribution of the filter words, where the filter words are the kind of the ailment or the issue. And then what we're going to do is just we're just going to plot it, and we can do data1.plot, and we just pass it. Come on, load. There we go. So plot samples from the frequency distribution, displaying the most frequent sample first. If an integer parameter is supplied, stop after this many samples have been plotted. So that's why I've put in 25, because otherwise it would just go on forever and it would be visually a mess. And I'll adjust that maybe in a bit. Let's just run it and see what we get. There we go. So from our imaginary hypothetical company who's admitted to all of these known issues with their injection, I don't know if you can read those, but let me just zoom in. What I'll do is I'll zoom in and just move it up a bit. Oh, that's in. Sorry, I can't. Let's just see if we can Control plus. No. Hopefully you can read that. I'll read them out. So the first thing is syndrome, positive antibody increased, herpes. So herpes, disease, abnormal artery, vein, zoster disorder, nerve, pulmonary sclerosis, paralysis, lupus, liver, pneumonia, factor. So as you can see, all of these crop up in that document more than 10 times. So again, it's not how many times it's happened to a human, it's how many different variations on these words, how many different symptoms that included these words are. So yeah, I just thought it'd be interesting just to analyze some obviously hypothetical data by a hypothetical company called PFYZER, and just what we've done is we've looked at a text file which you can harvest the data from that, typically using, in actual fact, the data was so it was so unmessed up, if that's the word. It was so neat, and everything was all pretty much it wasn't a CSV. It was separated by a semicolon, but all I had to do was just go in between each of the 9 pages and just remove the page number and the footer, and there I had it. I had a big text file. So if you could do this yourself, if you wanted, you could you know, Google for a company called something similar to PFYZER, and then you could analyze it, and you could look at all of the symptoms and the frequency with which those symptoms occurred. So really, this has been a look at using frequency distribution with NLTK. I've used a list comprehension here, but you wouldn't have to. You could just use a normal for loop. So yeah, I stripped out anything less than 3 letters. In fact, you don't even need that. So let's just simplify this a bit, shall we? So take that out. Data plot, let's change that from 25 down to 20 just to make it a bit more minimalist, should we say? So let's run it again. It does take a few seconds, but obviously it's preparing. We've got an error. Something's gone red. I need to put that back in. And let's run this. And we should get, there we go. Oh, we've got an outlier. Yeah. So it's all about data removing outliers. So the reason why we had, let's just undo that. Yeah, greater than 3. So if you had, I could do greater than 1. That might work. You can't have greater than 0 because otherwise it'll include a semicolon, and that will just completely skew your graph, and you'll get a huge spike. That's okay. So there we go. Syndrome, 80, positive antibody increased herpes. So herpes, yeah, herpes. If you run this without converting to lowercase, you'd have 2 lots of herpes, and you'd have 1 lot of herpes with a capital letter here somewhere, and you have another one down there. And they'd probably both have kind of lowish counts, but obviously by combining them, by converting everything to lowercase, then you get a true reading. There you can see apostrophe s as well. So that's another reason why you need to stick with 3. So we'll put 3 back in there, and I'll just show you what happens if I hadn't put in lower here. I'll run it again, and we should find it. I don't know if herpes will appear twice, but there it is once with a capital there. So it's there we go. So it's there once, if you can see my mouse there, and it's also there as well. So because it's got a lowercase h. So it seems herpes is quite a common hypothetical disorder with this hypothetical drug company list of potential side effects from their injection. But Obviously, it's not for me to comment, and it's all hypothetical anyway. So what we've done is we've looked at some hypothetical side effects of a hypothetical vaccine by a hypothetical company, and we've shown that some of the the highest frequency of the known side effects are things such as um, thrombosis and herpes, so and an embolism. So on that note, I'd like to thank you for watching, and obviously all this has been hypothetical, so hopefully I won't get deplatformed for just being hypothetical. So yeah, there we go. If you want to copy the code or have a play around with it, then it's there. Just kind of, I'm not going to put it on GitHub or anything, but yeah, if you want to find some kind of sample um, injection side effects, you could probably Google for something like that, and once you've got that, you can go through, and first thing to do is tokenize it. What we've done there on line 10 is basically remove any outliers, and I also then did I put in the lower for the key, and then just plotted it there. Didn't even use matplotlib really, just used data.plot, with 25 being the number of things you want to show along the bottom, and then cumulative equals false. So yeah, that's pretty simple, pretty good. Thank you for watching, and yeah, thumbs up if you like this, and yeah, see you again.